All right, let's start our notes for Chapter 7. On Section 7.1, I want you to go down to the bottom of the first page first, because what we're going to talk about is about systems of linear equations. And when we look at that word system, all it's going to mean is that we're going to put two lines on one graph. We've actually already started this. Remember when we did Section 7.6 with graphing linear inequalities, where we had all that shading? Now we're going to take the shading off, and we're just going to look at just the lines part. Now, every time we do a system, we're going to see that we have three possible situations. The first is that we could have two lines and they just simply intersect or cross. We're not talking about perpendicular or anything. We're just talking about the fact that they cross. And that point where they cross, right here, this one point is the one solution. Remember that that solution, that word, means that the point works in each equation. So we'll have two lines, and this pair, x comma y, will work in each one. Now the second situation, so think about two lines and having no solutions or no common points. The only way for that to happen is if we have two parallel lines, like so. And it doesn't matter what the slopes of those parallel lines are. Just the fact that they never cross means that we'll have no common points. So there are no solutions. So we'll see a graph that looks like this, and our answer will be the empty set because there won't be a pair x, y that works. Now, infinitely many solutions, meaning that all of the points are in common. Infinitely many, all the points are in common. Or shared. So that when we see that, again, picture your graph, and you're going to graph your first line, and then when you go to graph your second line, it's going to fall right back on top of it. So we'll just make it a little bit thicker so we can pretend, or really lines don't have any thickness, so all those points, they're exactly the same, all common points. And when that happens, we can write infinitely many solutions. So instead of having one solution, we'll have many. All right, so how do we do these problems? We're going to do it 3 different ways over the course of the week. And let's start with solving systems by graphing. Step 1 is going to be put your line in slope-intercept form. All right, so I'm sorry I had some computer stuff going on here. So to recap, you're going to put both lines into slope-intercept form. Remember, that's y equals mx plus b. And again, do it for both lines. Then you're going to graph both lines. Again, 2 easy steps. The third step is the most important one, and it's the one that's going to be the same for the entire chapter. You're going to answer the question by identifying the solution. And when you identify the solution, there are only 3 possibilities. You're either going to give me an ordered pair, an empty set, or infinitely many. If there's one solution or a point where they meet, you give me that ordered pair, x comma y. Or they are parallel lines and they never meet, you'll give me an empty set. Or they are the exact same line twice, and then you'll give me an answer of infinitely many. Let's take a look at a couple of example problems here. So the first thing we do is we check and see, are they in slope-intercept form? And both lines in number 1 are in fact in slope-intercept form. So now let's go ahead and graph. I'm going to make this first line in green, and the y-intercept is at -2. It has a slope of 1, so rise 1, right 1, to put in some more points. And this is the point where I can say, hey, remember how I told you should put in as many points as you possibly can? Right here's the reason why. Because if we put in all the points we possibly can, we'll connect our dots. Again, use your straight edge, don't do wiggly worms. We've got our first line. Now let's put our second line in. I'll go ahead and switch over to purple for that. So we'll do our second line in purple. And our y-intercept is at +2. So there's our starting point on the y-axis. And then our slope is -1, so down 1, right 1. And right there's our overlapping point. I can stop putting in quite as many points. Now I can use my straight edge. And to answer this problem, I need to read this point. Where is this point? We're always going to give it as an ordered pair. And in this case, the ordered pair is at 2, 0, or its coordinate pair. And that's all it takes. Let's work through number 3 together as well. Let's switch back to my green marker here. So I put my first line in green. First thing we check for is it in slope-intercept form? And it's not. So let's do some work to put it into slope-intercept form. That first line, to get y all alone, I need to divide both sides by 2. So that I get 1y. So y is equal to 1/2 x. That has a y-intercept of 0 because I'm adding nothing. And I will rise 1, move right 2 for my slope. Rise 1, right 2. Again, putting in as many points as I can so that this problem stays nice and easy. Connect my dots, preferably with a straight edge so you don't get wiggle worms. We've got our first line. Our second line is a similar situation. Y isn't solved for, it's not in slope-intercept form, so we need to divide. Remember that when you do that division, or even if it were a multiplication, you need to make sure you do that to every term, every piece, right? We're avoiding that giant fraction bar. So that we end up with y equals 1/2 x minus 2. So my y-intercept at -2 and my slope of 1/2. What do we know about parallel lines? Well, we know they have the same slope. Did you notice that my two lines, my green line and my purple line, both ended up with a slope of 1/2? That's how I know they're parallel. That's also how I know they're never going to cross. So instead of writing a solution as an ordered pair, since they don't have any common points, they never intersect, my correct answer is no solutions or empty set. Go ahead and pause it, and why don't you give problem number 4 a try. Give problem 4 a try.